So what we're going to do in example number 2 is, again, I'm giving us a double angle. So we're going to use an identity to try and solve this. Here's a hint. Right here we're saying, remember, I can't take cosine 2x and divide it by 2 to get cosine x. I can't do that. Cosine 2x is going to require us to use an identity. And when I think of that cosine 2x, I immediately think of cosine 2a. Now there's 3 cosine 2a's if memory serves, but the one I am choosing to use is this one. Could I use any other one? Of course I could, but this is the one I choose to use. So what we're going to do is I'm going to take out this cosine 2x and I'm going to put in this 2 cosine squared a minus 1. I'm using that one so I have cosine and cosine. I don't want to try to mix up sine and cosine if I can avoid it. So we are just going to stick with both of them being cosine functions. It's not a, it's x. So 2 cosine squared x minus 1, and that's going to equal cosine x. So I have a cosine squared and a cosine. So again, I'm thinking factoring. So let's get everything onto one side. So we're going to have 2 cosine squared x minus cosine x. I moved it over to the left. Minus 1. That equals 0. So we are perfectly set up to see if this factors. It's a trinomial, x squared minus x minus 1. Actually, 2x squared minus x minus 1. So we're going to ask ourselves, what two terms multiply? What two values multiply? If I do 2 times negative 1, that gives me negative 2. And those same two numbers add to give me the b value, which is negative 1. So if you're having trouble following the factoring, got to factor, ask me in class and we'll definitely go over some more of these. So what I'm thinking is negative 2 and positive 1. Negative 2 times 1, that's negative 2. Negative 2 plus 1, that's again negative 1. So that works. So when I factor this, this is going to become cosine x minus 2 and cosine x plus 1, and that equals 0. What I did is I unmultiplied this trinomial. Because there is a value in front, I am going to divide both of these numbers by this value. So cosine x minus 2 is going to become cosine of x minus 1. This does not go in evenly, so I am going to bring the 2 in front of the cosine x. And that equals 0. We are going to use our 0 factor property, which says if 2 factors multiply to give me an answer of 0, one of them, if not both of them, need to be a 0. This lets me solve for x in both cases to get this cosine x by itself. And then here I am going to get the cosine x by itself. I'm going to subtract 1 and then divide by 2. So I'm going to get negative 1/2. So we are trying to find the arc cosine or the inverse cosine of 1 and figure out what value on the unit circle is a 1 and what's that angle. And the same with the negative 1/2. Where are these values on my unit circle? Alrighty, where is cosine 1? And that's right there. I'm going to look back and I'm going to say, all right, should I use degrees or radians? Because I keep messing it up on the last 2 videos. And this one says radians. So in radians, this is at pi over 2. Now, where is my cosine negative 1/2? It's the third line up, because we're going to go boom, boom. We're looking at this reference angle right here all the way to the third one, and that is a reference angle of pi over 3, and it happens at the point negative 1/2. There's my cosine. Radical 3 over 2. Not only do I happen up in quadrant number 2, it also happens again down here in quadrant number 3 at negative 1/2. There's what I'm looking for, and negative radical 3 over 2. And again, there's my reference angle of pi over 3. So if we do 3 pi over 3 minus 1 pi over 3, we're going to get, so we've got our 0. I'm sorry, not 0, goodness. It was 1, and what is the angle for that? The angle for that is pi over 2. And then because of these two values, we are going to get 2/3 pi, 2 pi over 3, and then 3, one more, so that's going to be 4 pi over 3. And they only wanted us to find this on the interval, so my solution set in order is pi over 2, 2 pi over 3, and 4 pi over 3. There's my solution set. Boom. I would like this one. This problem is just like that last one, except now we're using sine instead of cosine. So what I'd like you to do is I'd like you to give this one a shot all on your own and come into class, and we will go over this one in class. So I'll see you when I see you, everybody.